السلام عليكم ورحمة الله وبركاته. In this section, we are going to speak about partial derivative. Quick look in the partial derivative definition. Partial derivative means we allow one direction to vary, which is here in this case the x coordinate, and we keep the y coordinate to be fixed. That's why we call it partial f with respect to x. Similarly, we may ask y to vary and we keep x to be fixed, then we call it partial f with respect to y. When we are differentiating with respect to x, we deal with others, all of it equal to 0. Keep in mind things from calculus 1, you make a mistake on it. If you have y equals to a constant k times f, the derivative will be the constant times the derivative. You are confusing with the second one, which is y equal to f plus k. When you make a derivative, it will be just f dash, which means the derivative equal to 0. Here in A, we want what is f sub x. If it is given to me f of xy equal to x cubed plus x squared times y cubed minus 2y squared, f sub x, or partial derivative of f with respect to x. Here we look only in x as a variable, so derivative of x cubed is a 3x squared. A derivative of x squared, it's 2x times the constant y cubed minus 0. Now, b, what's f sub y? Means what's the derivative of f with respect to y? It will be, now we are dealing with y to be the variable, so derivative of x cubed, let me change the color and write it again. This is what we have of xy is equal to x cubed plus x squared times y cubed minus 2 y squared. So if I want to find f sub y, means I am dealing with y only to be variable, so derivative of x cubed, the derivative constant, which is 0. X squared is constant, and the derivative of y cubed is 3y squared minus 4y. So we get this is equal to 3x squared y squared minus 4y. Now C, he want f sub x when x is equal to 2 and y equals to 1. So just simply replace x by 2 and y by 1. So you will get 3 times 4 plus 4, which is 12, plus 4, which is equal to 16. D, he want f sub y evaluated at 2, 1, means just go here and replace x by 1, so you will have 3 x by 2, sorry, and y by 1, minus 4 times 1. So that will be 3 times 4 minus 4, which is 8. Now, here we need to calculate what is derivative with respect to x, what's the derivative with respect to y. Let me say here, a, if we have f of xy equals to sine of x over 1 plus y. Remember in calculus 1, we said if we have f of u, the derivative will be a derivative of the outside times the derivative of the inside, which I mean chain rule. So here I have two things. I have the function sine, and inside the sine I have the angle, which is that one. So when I differentiate with respect to x, means y will be constant, So derivative of sine is cosine the angle. We don't change the angle as it is. It's not cosine x. It's cosine the angle x over 1 plus y. Now differentiating with respect to x, derivative of x is 1. So it will be 1 over 1 plus y because 1 plus y is constant. So derivative with respect to x will be 1 plus y. Now b, if I have the function f of xy, which is equal to sine of x over 1 plus y. Now I will rewrite it as sine of x times 1 plus y raised to the power minus 1. Now, why I wrote it this way? Because when I want to differentiate f with respect to y, our x, here we have first sine, and I have inside the sine, which is the angle I have here, minus, and inside that one I have what? 1 plus y, although the derivative will be 1. So when I make the derivative, a derivative of sine, it's cosine x over 1 plus y. And what's the derivative of 1 plus y raised to the power minus 1, which is derivative of the angle? It will be minus x 1 plus y raised to the power minus 2. The derivative of the inside, it's 1. So basically partial f with respect to y will be minus x over 1 plus y all squared times cosine of the angle x over 1 plus y. Now, example number 3, A, it says if we have f of xy equal to 4 minus x squared minus 2y squared, what's f sub x? Derivative with respect to x. Derivative of 4 0, derivative of x minus x squared will be minus 2x, and that will be derivative constant 0. Now, b, I have f of xy, which is equal to 4 minus x squared minus 2y squared. What's f sub y? A derivative for 0, derivative minus x squared 0, a derivative of minus 2y squared minus 4y. Now, c, we need f sub x, but evaluated at 1 and 1. So we have f sub x, it's minus 2x. We want to evaluate it at 1 and 1. So it will be minus 2. Now, d, we have f sub y, which is equal to minus 4y. This will mean f sub y at the point 1 and 1 will equal to minus 4 times 1, which is minus 4. Now, here we have two methods. One of them is using implicit differentiation. Okay. The second method, method 2, let me write it here, method 2, apply the theorem which says partial f with respect to x will be negative of f sub x, partial z with respect to x, say that will be minus f sub x by f sub z, where z is a function of x and y. That's a theorem, important theorem, which is a shortcut. For implicit differentiation, we are I want to remind you when we have in math calculus 1, when we have x squared y cubed plus cosine y equal to 0, when we differentiate x, we just say 2x because y is a function of x. But when we have y cubed, we say the 3y squared y dash. For cosine, we say minus y dash sine y. That's when we have in calculus 1. It's just a reminder. Now we have z is a function of x and y. Keeping that idea, we will deal with z like when we deal with y there. So if we have z cubed and I'm differentiating with respect to x, I will say 3z squared z sub x. Now, so if we have this idea in mind, what is partial z with respect to x? So partial z with respect to x, if I have x cubed plus y cubed plus z cubed plus 6 times x times y z plus 4 equal to 0. Now, remember, when we deal with implicit differentiation, what we will do, we differentiate term by term. So when I say x, I have x cubed here, so I will say the derivative is a 3x squared. I'm differentiating with respect to x, so this is y cubed, the derivative is 0. For z cubed, it will be, as we just said, a 3z squared z sub x. Plus, now here I have product 6x times yz. This is yz is constant, so derivative of 6x is just 6, and the constant will stay as it is. A derivative of 4 equal to 0 equal to 0. Now, we need to solve for z sub x. So I have, oh sorry, I have product rule here. Here I have product rule. I have, because z is a function of x, so I have this is 1, and that's a second. So derivative of the first will be 6yz, that's the derivative of the first times the second, plus the first, which is 6x. The derivative of the second, y is constant, the derivative of z will be z sub x, plus 0 equal to 0. Now, that's the derivative of the first times second plus first, and that's the derivative of second. Now, we need to solve step 2, solve for z sub x, which means keep z sub x in one side, the rest in the other side. So I will have here 3z squared z sub x plus 6 times x times y z sub x. The rest in the other side, which means minus 3x squared minus 6yz. So taking z sub x common factor, that will be 3z squared plus 6xy equal to minus 3x squared minus 6yz. So dividing by the coefficient of z squared, it will be 3z squared plus 6xy, coefficient of z sub x, sorry, 3z squared plus 6xy. That will cancel out, and we get z sub x equal to minus 3x squared minus 6yz divided by 3z squared plus 6y. Now, evaluation at the point minus 1, 1, and 2 means replace x by minus 1. You will get here minus 3 minus 6 times y, which is 1, times z, which is 2, divided by 3 times z squared, which is 4, 2 squared plus 6 times y, which is 6. So we will get here minus a 3 with minus plus minus a 12 minus 15. And here I have 12 plus 6. This will be 12 plus 6, which is 18. So that will be, if we divide by 3, we get minus 5 over 6. That's one method. The second method, I just said, we can set z to be a function of, we can set the equation as a function of x, y, z equal to 0, which means our f of x, y, z will be simply x cubed plus y cubed plus z cubed plus 6xyz plus 4. That's, we say this is method 2. We apply the theorem z sub x will be minus f sub x divided by f sub z. So applying this theorem, z sub x will be minus f sub x divided by f sub z. So that will be negative. Differentiating here with respect to x, it will be 3x squared. Now we're dealing with y and z constant, so 0, 0. The derivative with respect to x will be 6yz, and divided by f sub z. Now z is variable, x constant, so that will be 0 plus 0, 3z squared, and here we have z variable, so it will be 6xy. So we get z sub x is equal to minus 3x squared minus 6yz divided by 3z squared plus 6xy, which is the same we have here. It's exactly the same. You can see the final answer here. It's the same as that one. Now, then we just replace and we get minus 5 over 6. Now, if I want to have partial z with respect to y, again we have two methods. Method 1 by implicit differentiation, which means I have to deal with the derivative of z times z sub y. So I have x cubed plus y cubed plus z cubed plus 6xyz plus 4 equal to 0. My first step, differentiate with respect to y. So I have x cubed, its derivative is 0. Derivative of y cubed will be 3y squared. The derivative of z cubed, as we just said, 3z squared z sub y. Here I have a product rule. This is the first, and that's the second. The derivative of the first with respect to y, it will be 6x z, because that's the derivative of the first times the second, plus the first, which is 6xy, that is the first. The derivative of z, it will be z sub y, plus 0 equal to 0. Now, we solve for z sub y, which means we keep it in one side, we keep the others in the other side. So I will have 3z squared z sub y plus 6xy z sub y, that's in one side. The other side will be minus 3y squared minus 6xz. Taking z sub y common factor, which is my second step now, solve for step 2, solve for z sub y. So taking z sub y common factor, I will get 3z squared plus 6xy is equal to minus 3y squared minus 6xz. So z sub y will be dividing by the coefficient of z sub y, so it will be minus 3y squared minus 6xz divided by 3z squared plus 6xy. If we want z sub y at the point minus 1, 1 and 2, replace x by minus 1, y by 1, z by 2, so you will get minus 3 minus 6 times minus 1 times z, which is 2, and 3 times 4 plus 6 times minus 1 times 1, and that will be equal to minus 3 plus 12 divided by 12 minus 6, which is 12 minus 3 is 9, 12 minus 6 is 6, so that will be divided by 3. It's 3 divided by 3, it's 2. Method 2, apply the theorem which says if you have partial z with respect to y, that is equivalent to say negative of sub y divided by f sub z. So our function of x, y, z, which we take everything equal to 0, so our function will be x cubed plus y cubed plus z cubed. Now we are dealing with z as a variable, not as a function of xy. Now, so what is f sub x? Sorry, f sub y. We need what is f sub y? It will be 3y squared plus 6xz, because x and z will be dealt with to be constant. F sub z, now z is the variable, so that will be 0 and plus 0 plus 3z squared. Again, z is variable, these are constant, so it will be 6xy. Okay, so applying this theorem, we have now f z sub y will be negative of f sub y, which is 3y squared plus 6xz over 3z squared plus 6xy. So z sub y, it's negative 3y squared negative 6xz over 3z squared plus 6xy, which is the same as we get here. Okay, I'll stop here. This is the first part, and I will continue the second part once I arrive my office.